This is a brief tutorial on the periodic table. In 1869, Mendeleev came up with the idea of periodic law, followed closely by Meyer. Periodic law states that the properties of these elements will repeat themselves every so often as a function of their atomic numbers. The result of that is that elements in the same vertical column on the modern periodic chart, which we call groups, have very similar physical and chemical properties. The period are the horizontal rows of elements on the periodic table. Those do not have similar physical and chemical properties. The period or row transitions from metals to nonmetals. This is Mendeleev's original periodic chart, or at least a depiction of it, where you see some question marks for things that are missing or unknown or hypothetical and not yet discovered at Mendeleev's time. But note that the rows are certainly equivalent to the groups on the modern table. Things that would be in a column on the modern table are in rows on this version. Mendeleev typically gets most of the credit because he in fact did leave those gaps where it seemed there should be an element but it was missing, and based on the properties the elements didn't fit together, so he left an open space for it. He was able to determine the properties of those missing elements such as gallium or germanium, and because of that predictive nature of what he did, he gets more of the credit in many cases. This is the modern periodic chart, and it should look much more familiar to you, and the groups often have names. Group 1 elements, with exclusion of hydrogen there at the top, are called alkali metals. Group 2A elements are alkaline earth metals. Group 3 and 4 don't really have special names to them. Sometimes they're just referred to by the element at the top of the column, like the boron group or the carbon group or the nitrogen group, sometimes called nitrogens. But Group 6A are called chalcogens, 7A are called halogens, and then 8A are the noble gases. The elements in the center groups, the B groups, are transition metals. And then the elements offset to the bottom are called lanthanides and actinides. Notice element 57 and 89 there are lanthanum and actinum, and then you skip down to the bottom and then come back to that same row. Notice there's a skip from 57 to 72 and from 89 to 104, showing that those elements offset to the bottom were taken from between there. So the left-hand side of the periodic chart contains metals. What are those properties of metals? They tend to conduct heat and electricity very well. They tend to form cations by losing electrons. They form ionic compounds with nonmetals. The solid state's characterized by metallic bonding, which we may talk about in a different video. Nonmetals are on the right-hand side of the periodic table. So what are their properties? They generally conduct heat and electricity poorly. Carbon in the form of graphite is a notable exception. It tends to conduct heat and electricity fairly well for a nonmetal. They form anions by gaining electrons. They form ionic compounds with metals, but covalent compounds with other nonmetals. They form covalently bond molecules, but noble gases tend to be monoatomic. The metalloids are elements with properties that are somewhere in between, or a mixture of those metals and nonmetals, and cannot be clearly classified as either one. It might conduct electricity, but maybe not as well as a metal, for example. Metals tend to be malleable. You can hammer them out to a sheet or ductile drawn into a wire, where non-metals tend to be brittle. Maybe the metalloid has properties somewhere between there. Metals tend to have a luster, that means they're shiny. Non-metals tend to not have that. Maybe a metalloid is somewhat shiny but not extremely shiny. Those types of things. Many of these are effective semiconductors, most notably silicon. Now there's a stair-step function on the periodic table that separates the metals from the nonmetals, and the metalloids tend to lie along that stair-step. Metals are to the far left and up into the stair-step, and are about 80% of the elements. The best metals are farther to the left and towards the bottom of the periodic table. The nonmetals are to the right of that stair-step and are about 20%, or most of the rest of the elements. The best nonmetals are on the far right and at the top. Metalloids, there's only a few elements that are along that stair-step. Boron, silicon, germanium, antimony, tellurium, and astatine. Those are the metalloids. Tend to be more metallic as you go farther to the left and farther down as this depiction shows. Here is a version of the periodic table that is color-coded for metals, nonmetals, metalloids, as well as the state of the element at room temperature or 25 degrees Celsius. Notice all those shaded in that blue there are metals, where those in purple are metalloids, where many think hypothetically element 117 will end up being a metalloid, but that's somewhat subjective argument there. Those that are in the red are the nonmetals, and so you can see the division there. All those with symbols in black are solids, so you see most of those metals are solids, and the reds are gases. You can see many of the nonmetals are gases, and the blues are liquids. There's only two elements at 25 degrees Celsius that are liquids, and that's bromine and mercury. Gallium and cesium are sometimes thought of as liquids, but they actually will melt slightly above 25 degrees Celsius. So these are states at 25 degrees Celsius. This has been a brief tutorial on the periodic chart.